Um, this may just come as a surprise cause ready to I actually am able to actually get the answer, get to actually understand the most part of the video, but it may do some seem a bit too cocky saying that yo I know every single thing, but you know for this case uh, it did work out lah, it did work out. Okay, so okay okay, so the thing is this, it does um, first and foremost, like we do need to actually talk about um, the max heap and then talking about the min heap, because the thing is this, that all along our tutorials, right, all along the problems for heaps, right, we do struggle in terms of how do we actually utilize it, because in previous experiences is that they don't actually explain like baby step on how the mechanism work, but for this problem statement, the hard one, term as hard, that it's surprisingly easy for us to actually implement every single mechanism. Is being explained um, like explaining to like a 5-year-old child. And if in the future I'm gonna like make tutorial videos and whatnot have you, I really wish that it can be understood at this level. To me, this just feels like a net 2, a natural level 2. It feels like a skilled level 2, in my opinion at least, because it's just so easy to follow, and I just really like I enjoy the whole duration of the 40 minutes at least, right? So the thing is this, that there's a very big uh, miss of a conception of what is heap, and what is heap, and why is there a large adjective that is attached to the heap, and why is there a small adjective that is attached to the heap itself. So I really I'm first and foremost, I'm really so done when you give me the term heap, because I don't actually get it, and then now you add in a small, you add in a large, even worse, even worse. But for this very case, it was being explained, detailed, micro details to the point. So we're talking about heap here. So big big O of 1, quite surprising, right, that I am gonna actually explain our big O of 1 because it's that intuitive. So big O of 1, the reason why you call it the max heap, right, is that if you want to take value from the max heap, right, you in the machine, right, will instantly be able to actually recognize and then take out the value for you, the max value in the vacancies of a max heap. So for this very case, it will straight away tell you which one is the max, therefore the adjective max. And you may ask like what about the opposite, is it will take the minimum, but for this it take the maximum. That's the difference between the max heap and the min heap. So that's that. You begin of 1, you pull out the value, you pull out the max value is 3, you take out the 3. And for the min, you take out the mean, the smallest value is 4, you take out the value of 4 with a big O of 1 of operation. And to me, this example, it's very intuitive, is because that you have a bunch of numbers. So say you have 2, 3, 4 and 7, right? So in the mathematical term, you take out the median value, right? In the mathematical term, when you take out a median value, it's basically saying that you are taking out the median value of the bunch of the numbers. So for this very case, you have a 2, you have a 3, you have 4, you have 7. So you take the center value, it will be the in between of the 3 and the 4, and then that's how you actually derive on what is it about to actually take a median value. So for this very case, you know, you take the massive, you take out a massive, the instant value, you take out a 3 because that's the max. In the mean heap, you take out the first value, it's gonna be a 4. It obeys the law of the mathematical taking of the median equation. That's the beauty that, and it not only we referring to somewhere that it's which we are very familiar with, which is the median of a mathematical equation. You use that to actually apply to actually learn about a new term, maybe say called a heap for this very case, and the heap, and we are able to actually understand what is a max heap, why is a min heap. It's because we are drawing reference from somewhere that we actually am very familiar with, and that's why I really like this Leetcode version, because it just explain lah. For cause the previous tutorials and whatnot, I just get jumbled up here and there because I don't know what is heap, and then the whole problem statement is just going haywire. The start I don't really understand, I don't really know what is big or one. There's basically don't have like a familiar spot, an anchor point for me to actually bounce back and forth to. But for this very case, I'm able to actually bounce back and forth to. I'm very much convinced, I'm very much more relieved at this point. I'm very much comfortable making my moves on the map. So yeah, I think this was like the main part of the whole curriculum, which do make sense because I see the rest of the thing. There's actually nothing much already. Yeah. We actually spend most of the time doing this, and the most time that is actually spent on was you adding the value and then how you actually manipulate the value. So how it actually worked was that the very first thing, you add a tree over here, it's good, and then you do a conditional check. The first thing is first, you establish there's a max heap, there's a min heap, you establish the two vacancy, you establish out, you add a tree, put in a tree, and then you do a check. This check, you check the vacancy of the left and the right. Okay, ding, it passes. You add the 2, you put in the 2, and then the 2 comes in, and then you do the conditional check again, and then this time around, why? Because the vacancy for here is 2, here is 0, that's why then what do you have to do? You may ask, you will sort of first check which one is sort of the max. Basically, bigger of 1, you take out the value, and then you take out the 3, you pop the value 3, and then that will be bigger of 1, you recognize the value, bigger of 1, you take it out, you pop it off, right? You big O log of n, I think it's n if I'm not wrong. I think it should be n, that on how you search a value, I'm not too sure, but there's something to do with the log of n, something like this, and then you insert a value, which is another big O of 1 operation, because adding and removing is a big O of 1. Something in between, I'm not too sure what is it, but I think it's so, I don't know what the process was, but I think it's a big log of n. This process is adding and removing. I'm saying for this very case. So, and then after you do all this, do a conditional check, because this is 1, this is 1, then you think, you do a pass, and then you move on to the next operation. So you move on to the next operation, you add in the 7, you put in the 7, it goes right over here, the 7, and then you do a fulfillment checker, and then because here is a vacancy of 2, I mean the fill up slot is 2, here the vacancy is 1, I mean the fill up spot is 1, you do a pass, you move on to the next value. Okay, there's something that they do also check that I actually miss out, is that the another condition is that the value on the max heap, right? So for this very case, you have a 2, and then you have the 3 over here, right? And then later on we add the 7, right? So add on the 7. So the thing is this, here's a 3, 2, so 3, 3, the 7. So first thing first is that the 7 is not less than equals to 3, right? So you got to sort the values, right? I think when they do the comparison, it's always the max. So for this very case, it will be a 7, that means it will be a 3, and then you compare these two numbers, and this one you bring over the 7th, this one you free, you bring in the value over here, because you're doing the conditional check in the very first place. So so for this very case, come to here. So the next value, you add in the 4, put in the 4, but this time around, 3 is gone, right? 7 is also gone. 1, 2, 3. Three is the 1. Next is the 4. Pick out the 4. Pull in the 4. 2, 3, 4, 7. But the thing is, I don't really think that it's how the value explain, but it works for now. Okay, so that's that law. Oh yeah, the other thing is like talking about the um we bring a small heap, we bring a large heap, but for this very case is that on a small heap we apply the spell max heap because we want to take out to fit the criteria of the mathematical term of the so that you are able to take out the 3, and for this case a large heap do a min heap to fit the math equations, and then you take out the 4, so you fit the criteria. That's why on a small heap you apply max heap and vice versa. So yeah, we do all these operations already, and then we do a get median, which is what we're gonna do over there later. So you, you take out the you activate this and you activate this, and then you add them together and then divide by 2, you get a final answer. So yeah, there you have it. Everything comes to an end.